Hey, good morning, guys. Happy Sunday to you. I am posting this video so you could take notes on today to get ready to do the topics tonight and be ready for class tomorrow. And I'm going to try to give you a few more examples because this stuff can be a little tricky. And the first thing I want to do is give you a really good method to handle word problems. What this next section is it's word problems dealing with distance, rate, and time, and a little bit of another topic, which will come in the last slide. But I wanted to give you a way to tackle these distance, rate, time problems. And here it is. So the first thing you're going to do is I want you to realize that there is a nice way to create a chart. Now the chart is a little tricky, okay, in that there's one step that I always used to screw up on, and I never understood how charts work until I figured this out. So here's the thing. Usually you're comparing one, two, or three things. So let's say they're talking about train one, train two, or they're talking about runner one, runner two. Okay, that's where that goes. It goes in here. So let's say we're talking about car one and car two. Okay, that's where that goes in the chart. But here's the part that's actually the mathy element of it, okay? So right here is where your formula goes. Now, if we weren't doing distance, rate, time, it would be a different formula, but we're just going to handle it with the distance formula. Remember, that's a dirt formula. Always think about that. D is equal to RT. So the way you put it in the chart is this way. You go rate times time is equal to distance, okay? So your rates are going to go here. Your times are going to go here. But here is the most important part. And I'm going to put it in red, maybe a little thicker. Okay? D, this column here, this column, actually the easiest way to say this column, do not fill this column with info from the problem. So if they tell you that the distance is 100 miles or 235 miles or 500 kilometers or whatever, don't fill it in. It is the biggest temptation and it is the hardest thing to resist. All right? Don't do it. Okay? What you need to know is that this column comes from these two. This column here comes from these two. Okay? Oops, I didn't realize. I thought it was on the height thing. Okay, here we go. So, for example, okay, the rate goes here. Rate one is going to go here. Rate two here. Time here. Okay, so let's say they said the rate was 5 and you didn't know the time. Okay, and this rate was 8 and we didn't know the time for right now. Okay, the distance is going to be rate times times equals distance. The distance is going to be 5t. You get this column from these two things. Okay, this one is 8t. That's the most important thing. That and one more thing. Time means time passed. It means time passed. How do I say that? Like, so for example, 1 hour, e.g., 1 minute, 1 hour, 1 day. Time means time passed, not the time of day. Do not use times of day for time. If it says 12 o'clock, don't put 12 o'clock. That is the mark of a time, but it is not time passed. Okay, those are the most important things about this. Let's take a look at the first problem. I'm going to do 3 distance, rate, time problems and 1 solving for each of the different things. So this one, let's read it, okay? And when you read it, I don't know about you, but I personally go through and I highlight and underline things and write them down, okay? So 2 cars leave towns at 300 kilometers apart. Okay, so for me, this is what I'm envisioning. Here's town 1, and 300 kilometers away is town 2. Now, you don't need to do this if it doesn't help you. It does help me, though. Okay, it just gives me an idea. Okay, we're talking about 2 towns. They're 300 kilometers apart. Okay, 2 cars. We're talking about 2 little cars. Okay, you don't have to draw the little cars, but hey, let's do it. Okay, so here's the little car. This is my sad little car, especially on here. There's one little car. This is so hard. I can't put my elbow down, so I'm like drawing in space. Okay, there we go. Okay, 2 cars leave whatever at the same time and travel toward each other, so we know they're going toward each other. Okay, at some point they're going to meet, and I'm sure that's what they're going to say. They travel toward each other. 1 car's rate is 16 kilometers per hour. Okay, here you go. Ready? It's 16 kilometers less than the others. Wow, I don't like the way that looks. I'm sorry, guys. Still dealing with this program. I think this one has a better highlighter, but I don't know. This one has a better pen, I think. Okay. Okay, 16 kilometers less than the others. Okay, so think about that for a second. What that means is that it's going to be, one is going to be faster and one is going to be slower. Sometimes it's nice for you to decide which one is going to be faster. So let's say car 1 is going to be faster. Okay, this one's slower. It doesn't matter. You got to pick one. Okay. Okay. If they meet in 2 hours, okay, so now you have some more information. 2 hours, what is the rate? Here's your question. This is going to tell you what you're looking for. What is the rate? And they actually tell you how to answer it right here in kilometers per hour. So we're going to set up a table. Okay. And we're going to set up the table like this. Okay, we're going to go rate times time equals distance. And we're going to go car 1 and car 2. Okay, what is the rate of the first car? Well, we don't know that. That's what we're looking for. So when they say, what is the rate? They are literally telling you what is your variable. So one of these cars is going to be R. Now you get to choose which one. Some of you guys maybe pick faster or slower. I'm going to pick let's see, 1 car's rate is 16 kilometers less than. I'm going to pick the faster one. Okay, I'm going to make this car. Oh, wait, it says, what is the rate of the slower car? My bad. If they ask you a specific one, make R that one. Okay, so I'm going to make car 1 the slower one. And I'm going to write that slower. And that's faster. Okay, so if this is slower and it says 1 car's rate is 16 kilometers less than, that means this guy is going 16 faster, plus 16. Right? If the slower car is going, and I need to erase this, by the way. We don't want to make that R. We made this one R. This is R. This is going to be R plus 16. Yeah. If they ever ask you, what is the rate of the slower car? It's easiest to solve the problem picking that one as your single variable, your unknown. All right, what's the time? The time that has passed is 2 hours. So we're going to go ahead and put in 2 and 2. Okay, now to get D, all you do is multiply across. 2R and 2 times R plus 16. So now you have the distance that car 1 went. So the distance that the car 1 went, this one, is 2r. You don't need to write this in the picture. I just do this because I'm just trying to identify the slower and the faster car. Okay. What does it say about them? It says that they are 300 kilometers apart. So this car and this car are going to travel towards each other. And eventually they're both going to travel 300 kilometers. So the equation that you're going to set up is going to be, sorry, makes it so hard to do this. Okay. Okay, it's going to be 2r plus 2 times r plus 16 equals 300. And from here, I'm going to assume that you know how to solve it. Okay, I'm going to go quickly. Distributing. I would never do this on my paper. I would make it so much neater. I would add another paper. I just want this table to be on the same page, so you know it's my issue. 4r plus 32 equals 300. The idea? 4r equals 32 minus 300 is 268. And then divide by 4. 4 goes up to 26. 6 times it just 67. Okay, so the answer is 67 kilometers per hour. There. Okay. Let's take a look at the next problem. I'm going to change the way I'm writing to see if this makes it any easier. Okay, so look at this problem. 2 trains leave the station. Get a different color pen. Okay. 2 trains leave stations 456 miles apart at the same time. Okay. That doesn't matter. The fact that they left at the same time only matters that we understand that the time is going to be the same. Like the passing of the time is going to be the same and travel toward each other. One train travels at this rate and the other one travels at this rate. How long? See, it's asking you how long. That means we are looking for time. Time. How many hours? That's what it's asking you for. If it asked you for minutes, you need to take that into consideration. I mean, you need to pay attention to the units, but it's asking for time. So here we're thinking, okay, we've got 2 stations. They are 456 miles apart. You've got one train going this way at 85 miles an hour. This one is going 105. Okay. At some point, they're going to meet and they want to know how long did it take. So in the distance equals rate times time, looking for time. Okay, so here we go. Let's draw the chart. Okay, rate, time, distance. Do not be tempted to put that 456 there. Doesn't go there. Okay, this is T1 and T2, train 1, train 2. One rate, train 1 is 85. The time is going to be the time. That's what we don't know. That's what we don't know. And that's what we're going to put in, 105 T. Okay, now to get D, multiply across 85 T, 105 T. Okay, and now you're going to write your equation. So I've got 85 T, this one, the distance that it's going to travel, and the distance that it's going to travel when you add them together is going to be 456. So I'm just going to go ahead and write that on another page. Okay, so I'm going to do this. Come on, honey. Okay, I'm going to add a page real quick. Okay, so we got 85T plus 105T equals 456. Okay, you add them together, you're going to get 190 equals 456. Time is equal to, and then divide. Now you can use a calculator for this. I assume, let's see what they say about the time. They say do not do any rounding. Okay, so if you do a calculator, which, let me see if I could just do this. Okay, 456 divided by 190. Okay, the answer was 2.4 hours. Now, sometimes they would ask you to convert that to minutes, and that's a whole nother problem. You have to take that and multiply by 60 minutes in an hour, but we didn't have to, so leave it as is. Okay, next problem. Michael drove to the mountains last weekend. Okay, there was heavy traffic on the way there, and the trip took 9 hours. When Michael drove home, there was no traffic, and the trip only took 4 hours. Holy crap, that's a long, long, long time. That's double the time. I don't think I would go if it took me twice as long. Anyway, if his average rate was 40 miles per hour faster on the trip home, how far away does Michael live from the mountains? All right. So typically when I do a word problem, I read it once, which I didn't do in the first two, because I had already read them in the, in the beginning. But I typically read it and then go back. Make sure you know what you're looking for. So it says how far away. So what are we looking for? Distance. And we're going to find that distance in miles. Okay, so let's start with drawing our chart. This is a there and back problem. It's where you go there and you go back and the rates are different. Okay, so like Michael left and he went to the same place and then came back again. Okay, he went there and he came back. And it's asking you, how far away does Michael live from the mountains? So it's not asking you for the total trip. It's asking you for this part right here. One of these, either the distance there, distance back. It's going to be the same thing, right? So rate times time equal distance. I do not like the skinny pen. Okay, so we're going to go there and back. Is rate there? Okay, here's what it says. It says that the trip took 9 hours there and it took 4 hours back. It says his average rate was 40 miles per hour faster on the trip home. Okay, 40 hours per mile faster on the trip home. Okay, so what does that mean? Okay, sorry, that took me a moment to figure that. Okay, so here's the deal. They're not giving us the rates. Okay, if they give us the rates, then we'd be able to calculate the distance right away. So that would be easy, right? Okay, but they're not. So we're going to have to pick one of these to be R again, and we're going to have to solve for rate and then use that to solve for distance. So if 40 miles faster on the way home, so let's make there R, and back is R plus 40. 40 miles per hour faster, yeah? So again, distance comes from multiplying these two things, 9R and 4 times R plus 40. Sometimes you expect a problem to go one way and it doesn't, and it takes you a moment. And that's what happened. I'm like, what? Oh yeah, okay, here we go. All right, what do you know about the distance there and the distance back? Look, what do you know about the distance there and the distance back? They are equal. Okay, so that's how you set up your next equation. They are going to be equal. So let's go ahead and do that. Okay, and let's go back. It's 9R equals 4 times R plus 40. Okay, 9R, that's not an R, that's a 4. 9R equals 4 times R plus 40. Is that right? I'm just going to make sure before. R plus 40, yes, indeed. Okay, so again, distribute. Okay, get your r's together. Subtract 4r from both sides. You'll get 5r equals 160. Divide by 5. It's in there 3 times 32. So the rate of the trip there, that was there, is 32 miles per hour. Well, they didn't ask us for rate. They asked us for distance. So you got to go back and plug it into this right there, 9r. That's the distance there. The distance there is 9. You could plug it into the way back, but, well, no, you can't. Wait. No, you can't. You'd have to figure out the rate back. Okay, so 9 times 32. 9 times 2 is 18, 28, 288 miles. Now, you could check it with the second equation. The second equation says that it's r plus 40, okay? What would be the rate? 32 plus 40. 32 plus 40. Oh my God, you guys, think about this in reality. 72 miles per hour home and 32 miles per hour there. Boy, I'd be listening to a book or something on the way over there. That'd be rough. All right, 72. So you'd be plugging 72 into this equation here. And let's see if we get the same thing. 72 plus 40. Plus 40. 4 times, you don't have to do this. I'm just doing this to prove that it worked. Is that right? 102. I mean, 112. Okay, 11. Yeah, okay, good. Which is 448. Did I do something wrong? I probably multiplied this one wrong. No, I didn't. Took 4 hours, 9 hours, 9r. Did I do something wrong here? Oh, I added 40 twice. I'm a dork. Sorry, guys. Hopefully you're just using this time to copy stuff down. Okay, let's try this again. It would be, sometimes your check screws you up, but at least it makes you fix it and figure it out. Okay, so it's 72 miles is r plus 40. I added it twice. I should have just plugged it in like this. 4 times 32 plus 40. I shouldn't have tried to keep thinking it through. So that would be 4 times 102, 1 plus 72, sorry, 72. I need somebody to give me all these fast facts really quickly. Okay, and then you would get 288, and it checks. Okay, obviously you could have stopped right there. Okay, next type of problem is going to be finding the side lengths of rectangles given one dimension and an area or a perimeter. So what they're going to do is they're going to give you either an area or a perimeter, and you need to find the dimensions of the rectangle. All of these are really easy if you just draw a picture, okay? It says the perimeter of a rectangle is 322. That means you walk around this rectangle and you're going to get 322 meters. Okay, that's the distance all the way around. Okay, if the width is 66, it doesn't matter which side you pick as the width. I usually pick the shortest one, okay, because length seems longer than width, okay? That's not always true, but that's kind of the way we think of it. What is its length? Okay, so let's go with L. We don't know. What is its length? So this is 66 and this is L. And we know if we walk all the way around, we're going to get 322. So we write the equation. You can write it like this. I'm going to show you the formula way. But this is the low key way. This is the way you do it if you're just thinking about it. Okay. And then you would solve that equation. The formula, though, for perimeter is 2 times length plus width equals perimeter. And then what you would do is substitute in. The perimeter is 322. The length is unknown. and the width is 66. When you multiply, you'll get 2L plus 66 times 2. Try to do that in my head and screw up. 132. Okay, 132 equals 322. And that's what I would get here. See? 2L plus 132 equals 322. And then you keep solving. 2L and then keep going. I'm not going to keep solving because once you figure out L, you'll have the length. Okay? Taking a look at the next question, which is the pool. So I'm going to go ahead and clear this frame because you guys can pause it if you need to. Okay? Wait, I didn't want to do that because I lost my problem. This is interesting. I guess I could just backtrack the entire problem, which is very strange. I don't think I like this. Maybe next time I'll double the actual, what do you call it? I'll double the problem. Okay, let's take a look at that. Now I can erase this. Okay, we'll erase that. Okay, all right. Okay, by the way, if you're listening to this on YouTube, you can always double the speed or slow it down, I believe. Okay, the area of rectangular pool is this. So now they're giving you another rectangle, and now they're telling you the area. Typically, I put the area inside. Okay. And yes, of course, it's meters squared. Area is always going to be squares. They're always talking about how many squares fit in the area. If the length of the pool is 91, what is its width? Okay, so we put W. Same thing. Use the formula. I have a formula that I always tell kids to use, and it's this. Formula, you write the formula first, then you substitute in the values, substitute, and then you solve it. I say formula, substitution, resolution. That is the formula for how to do these without screwing up, to be honest. So like you would go length times width of a rectangle equals the area. Well, what's the length? 91. What's the width? We don't know. What's the area? 6734. Do you see what I did? I plugged them in vertically so we can read. The length is 91. The width is unknown. The area is this. It keeps your brain in line. So you get 91W equals 6734, and you divide and you will have your width. Okay, moving on. By the way, you guys should divide and have the width there. So you should have your little calculators ready. I don't know why I don't have one. I need to get me a little calculator here. I mean, I have my phone, but I don't like using my phone. All right, so here we go. Here's another one. Same thing. Area of a rectangle. So we start here, 7663. The length is 97. What is its width? So length times width equals area. 97 times W equals 7663. And solve to get your W. Pool, the perimeter. So P is equal to, and in fact, I'm not even going to draw the rectangle of this pool particularly. I'm going to write P equals 2 length plus 2 W. Okay, that's another way of putting it. If P is equal to 2 times the length plus W, if you distribute, you're going to get that. So you can use either formula. They're both good. Okay, so again, formula, substitution, resolution. What is the perimeter? 252. What do we have? The width. So we don't have the length. That's what they're asking for. 2 times 54. And then you would solve that. Okay. All right. This is interesting because this is going to make you name one side in terms of the other. Typically, they give you width as W. I mean, honestly, they usually make width unknown. I don't know why. They don't need to, but they do. Okay. The length of a rectangle. So now they're defining your length. Okay. I can put an L there, but we're doing like the Algebra 1 version where we're only using one variable. So they're going to define length in terms of width. It says the length of a rectangle is 6 yards longer than its width. So what is its width? Okay, well, first of all, let's keep reading. If the perimeter is 72, so we know perimeter, find its length and width. Okay, well, we know that the length is 6 yards longer than the width. So right here, W plus 6. And you don't need to write this either. If you can just jump to this, it's fine. There. Okay, so perimeter formula is just walk around and add up all the sides. Okay, 2 times the width, which is 2W, plus 2 times the length, which is W plus 6. And what's the perimeter? Perimeter is 72. Okay, and then you solve that, working that out. Okay. So I realize I'm not finishing a lot of these problems for you because they are pretty much the same thing. I mean, I guess you need to let me know if I need to continue this, like if it helps, if you feel better with it. Probably a lot of you would feel better if I did do this. So let me just finish this one. So W is equal to 15. Yeah, I probably should finish this one because it says find its length and its width. Well, W equals 15. So what is this? It's going to be 15 plus 6, which is 21. Okay. The last problem is basically solving for any variable. You should be able to be given a formula and solve for any variable. And in this case, it says solve for x. Okay, so there's x. X is hidden inside the parentheses. It's stuck in that parentheses, so we got to get it out. So ask yourself, what's my problem? Well, the problem is x is stuck in there. Okay, what do I do to get it out? What's the only thing you can do? And that is to distribute. Okay, to distribute, distribution is great. It gets things out of parentheses. So 10x minus 10a equals y. Yay. So now we got x out, but we got to get it by itself. So we got to get rid of all the stuff that's attached to it. So we're going to go ahead and we are going to get rid of, like we ask our questions. What do we want to get rid of? We want to get rid of both the 10 and the 10a, the negative 10a here. Get rid of the stuff that is added and subtracted first. Okay, so if you did this, by the way, I don't often do this, but you can actually just jump it over and change the sign. When you do this, let's say you do this and you cancel, and you get 10x equals, okay? Well, you can't add these. They're not like terms. Don't even try. Just list them. There they are. Okay. That is the ugliest A ever. I'm sorry. Let's try to write it better. There we go. We still need to get x by itself. So we got to get rid of the 10. Ask the questions. What do I want to get rid of? 10. What is it doing to the variable? Multiplying. What do I do to get rid of it? Divide. So you can't just divide one thing. You've got to divide the whole side by 10. And herein lies the last little element of problems. Now, most times in advanced algebra classes, you would actually just leave it like this. I don't know what Alex wants you to do. It might want you to separate these two fractions. Okay, you could separate them into y over 10 is equal to negative 10a over 10, and then these would cancel. Wait, did I put equals? I meant minus sign right there. Why did I put that equal sign there? Get rid of that little guy there. Minus 10a. I don't know what the heck I was thinking. Okay. And that would cancel, and you'd end up with just a minus a. So both of these are accepted answers. I don't know which one Alex would do. So you need to, I don't know which one Alex would ask for. So I guess you guys will figure that out. And that's it. I decided to put them in one long video just to make it easier. You guys can pause when you need to.